Let us study the horizontal asymptotes of rational functions. We will introduce asymptotes, explain horizontal asymptotes, and show us how to calculate the horizontal asymptote of a rational function. So an asymptote is a line that a curve approaches as it tends towards infinity. In this case, in this graph right here, we can see that there are two asymptotes. You have a vertical asymptote, which is x equal to -1. So if we draw a vertical line at -1, you will see that the graph will never touch that point as it tends towards infinity. And then you have the horizontal asymptote, which is the x-axis right here. In the second graph here, we have the same vertical asymptote, but the horizontal asymptote is moved up 1 unit. So it's y equal to 1. In this lesson, we're just going to focus on the horizontal asymptote. Now here are the rules for the horizontal asymptote. If the degree of the numerator, so the degree, if I had something like x squared divided by x squared plus 1. So here the degree is the largest exponent on the x value in the expression or in the function. So here we can see that 2 is the degree. So if the degree of the numerator and denominator are the same, divide the coefficient. So what it's saying here is, so our degree is 2 and our degree is 2 here, so our coefficient is 1, so we divide 1 by 1, and that's going to give us a 1. Now, if the degree of the numerator is less than that of the denominator, so if we had a situation like x over x cubed minus 5, for example, when you have a situation like this, your horizontal asymptote is going to be y equal to 0, which is your x-axis. And if the degree of the numerator is greater than that of the denominator, we do not have a horizontal asymptote. We have a different type of asymptote, which will be introduced in a different video. So what we're talking about here is if we have something like x squared minus 1 divided by x plus 5. So in this case, the degree in the numerator is 2, the degree in the denominator is 1, so we cannot have a horizontal asymptote here. Let's put this to practice. So it says, what is the horizontal asymptote of y equal to 3 over 2x? Let's look at the degree of the numerator. The degree of the numerator is 0. So degree 0 divided by the degree of the denominator is 1. So degree 1. What we're told here is that if the degree of the numerator is less than the degree of the denominator, then we have a horizontal asymptote. Sorry about that. The horizontal asymptote is going to be y. Horizontal asymptote is y equal to 0, also known as the x-axis. Let's look at another example. So the degree in the numerator is, so we have degree 2, and then the denominator we have degree 2. So what we've shown here is that when we have the degree the same in the numerator and denominator, we divide the coefficient of the terms. So here, the coefficient here is 1, the coefficient here is 3. So our horizontal asymptote is going to be y equal to 1 over 3. Another example, y equal to 3x over x squared minus 5x minus 14. So we have a situation where, let's look at the degree in the numerator is 1, the degree in the denominator is 2. So because 1 is less than 2, then our horizontal asymptote is going to be y equal to 0, also known as the x-axis. And finally, what is the horizontal asymptote of y equal to 5x cubed divided by x squared plus 14? So let's look at the degree in the numerator. The degree in the numerator is 3. The degree in the denominator is 2. So 3 is greater than 2, so we have no horizontal asymptote. Whenever the degree in the numerator is greater than the degree in the denominator, we have no horizontal asymptote.